Okay, at a very high level, let's continue and talk about the generalities of the different link layer services. So basically the services that the link layer provides. So basically there's the basic framing and link access services. These basically um, encapsulate the datagram into a frame, and as in any layer, a header and a trailer is added. Um, at least most layers at least add a header. We have a header and a trailer in the link layer. And it also provides channel access if this is a shared medium. We're going to talk about that a little more, what that means. And the addressing in the link layer is usually what's called a MAC address, which we're going to talk about further as well. And the MAC address is used in frame headers to identify a source and destination, but this is a different identification than the IP address. You're going to see it's going to play out a little bit differently. Additional services in the link layer include the capability for some flow control, and we're going to take a look at the flow control mechanisms. That's basically, so just as in the upper layer, um, we don't overflow a receiver by a sender, so we have some level of flow control in link layer. There's also some error detection. We're going to actually skip error detection and error correction. We did cover that in 475, so I'm not going to cover that again in our review. And link layer services come in half duplex, half duplex and full duplex flavors. Basically, half duplex meaning a node can send and receive, just not at the same time. Um, and that's also true of the physical layer. We'll talk about that a little bit. But these days, everything, for the most part, is pretty much full duplex configuration. So where is the link layer implemented? So basically, just like in the network layer, the link layer is implemented in every single host. So the difference is you're going to change protocols as you go across the network in the link layer as opposed to the network layer where you're just using one protocol. So the link layer is in every single host. It's usually implemented in hardware, usually in the adapter or the interface card, or maybe on some sort of chip. Um, that are basically Ethernet cards that implement 802.11 cards as well, that implement all of the link layer functions. And so basically this is a combination of hardware, software, and firmware, but obviously there's a lot of timing requirements, so a lot of this is in hardware and firmware, although you do have some software settable parameters. So how do the adapters communicate? So on a very simplistic level, imagine here you have a sending host. So you see on the sending host, from a hardware point of view, you have the system bus that's some sort of network controller, whether it's an Ethernet card or Ethernet chip or a NIC card, receives a datagram. It encapsulates the datagram with the frame, with both a header and a trailer. And it's received at the receiving host after possibly going through many different types of link layer networks, although this could be a simple, this could also be a simple local area network. It doesn't matter. The process is still the same. It's received at the receiving NIC card. The link layer frame is removed, and the datagram is sent on the system bus. So what's happening on the sending side, besides encapsulating the data, it adds error checking bits, and it has reliable data transfer and flow control functions, similar to what we looked at at on TCP from a conceptual point of view. On the receiving side, it looks for errors, and it also has reliable data control and flow control, reliable data transfer and flow control functionality. And like I said, it extracts the datagram and passes it on to the system bus to be eventually received by the upper layers on the receiving host.